The Nancy Grace Roman Space Telescope, formerly known as JWST, the Wide Field Infrared Survey Telescope, is a space-based observatory of the next generation that will answer pressing concerns about the universe. The mission will create enormous panoramas of the universe in order to disclose the secrets of dark energy and dark matter, discover planets beyond our solar system, and investigate a variety of other astrophysics and planetary science topics. Roman will be one of the most essential tools we've ever created for studying the universe due to its ability to help solve numerous cosmic mysteries. The Roman Space Telescope will investigate dark energy, measure the history of cosmic acceleration, search for extrasolar planets. Launch is scheduled for the middle of the 2020s, with the most likely date being 2027. Welcome back to my channel. Next Generation Space Telescope, the Nancy Grace Roman Space Telescope. Nancy Grace Roman, known as the mother of the Hubble Space Telescope, was born on May 16, 1925 in Nashville, Tennessee, and passed away on December 25, 2018. Obtaining the approval of the U.S. Congress for the Hubble Space Telescope was one of the greatest challenges of her career. She was dubbed the Mother of Hubble due to her contributions to the mission. When asked what she believed was Hubble's most fascinating discovery, she replied that is the dark energy. Hubble confirmed the astonishing initial measurements that the universe's expansion was accelerating, and extended these measurements to higher redshifts. These findings thrilled scientific community. It is very good that NASA dedicate its next major space observatory to her name, and tasked with enhancing our further understanding of dark energy. Roman will help uncover the mysteries of dark energy and dark matter, search for and image exoplanets, and investigate numerous topics in infrared astrophysics, when it launches in May 2027. The Roman team painstakingly assembled nearly 2,000 individual components, many of which were custom designed by Goddard engineers, to construct this structure, a significant achievement that took several years to achieve. The primary structure that will function as the bones of NASA's Nancy Grace Roman Space Telescope has been relocated to the large clean room at the Goddard Space Flight Center in Greenbelt, Maryland. The spacecraft vehicle, the primary support element for Roman, will now be constructed atop this skeleton. The Nancy Grace Roman Space Telescope is administered by NASA's Goddard Space Flight Center, in Greenbelt, Maryland, in collaboration with JPL and Caltech IPAC in Southern California, the Space Telescope Science Institute in Baltimore, and a science team comprised of scientists from various research institutions. Ball Aerospace and Technologies Corporation in Boulder, Colorado, L3 Harris Technologies in Melbourne, Florida, and Teledyne Scientific and Imaging in Thousand Oaks, California, are the primary industrial partners. JPL, which manages the instrument for NASA, designed and is constructing the Roman coronagraph instrument. The European Space Agency, ESA, the Japanese Aerospace Exploration Agency, JAXA, the French Space Agency Centre National d'études spatiales, CNES, and the German Max Planck Institute for Astronomy, MPIA, all made contributions. Roman's enormous field of view will allow the mission to produce infrared images that are approximately 200 times larger than those produced by the Hubble Space Telescope, while retaining the same level of detail. The spacecraft is anticipated to collect significantly more data than any previous NASA astrophysics mission. It consists in part of a central cylinder with a deck on top, that will sustain the majority of the observatory. Each of its 6 sides contains a compartment for housing the observatory's essential electronics and other hardware. The primary structure will contain the spacecraft's power, attitude control, and propulsion systems. The high-gain antenna will be installed beneath it, and the spacecraft will be attached to the rocket during launch by the lowest portion of the primary structure. The structure is composed primarily of a robust lightweight aluminum alloy. The majority of its exterior is partially hollowed out in a triangular pattern, known as an isogrid, to reduce its weight even further. Despite its size, approximately 14 feet, or 4.3 meters in length, 12 feet, or 3.7 meters in width, and 6.5 feet, or 2.0 meters in height. The primary structure weighs only 3,600 pounds or 1,600 kilograms. Engineers affixed a protective coating to the satellite, in order to shield it from the environment on Earth, and ensure the proper temperature profile in space. In addition, the team has conducted fit checks, to ensure that all components are precisely positioned, so that subsequent components will connect correctly. The primary structure has now been set on the Pantheon, a large assembly platform constructed for Romans. In June of 2023, the team will connect the spacecraft's electronics. The harness, which functions as the spacecraft's nervous system, is currently being attached to the spacecraft. Recently, NASA delivered the core of the Nancy Grace Roman Space Telescope to Ball Aerospace in Boulder, Colorado, for integration into the WFI, Wide Field Instrument. The FPS, focal plane system, is the central component of Roman's camera. When the mission launches in May 2027, astronomers will use this system to collect high-resolution images, to help unravel the mysteries of dark energy and dark matter, discover exoplanets, and investigate a variety of infrared astrophysics topics. Each of Roman's 18 detectors contains 16.8 million minuscule pixels, providing the mission with exceptional image resolution. Through these eyes, we will be able to peer through cosmic dust and across immense expanses of the universe, creating high-resolution panoramas of the cosmos. Roman has one of the largest focal plane arrays ever flown aboard a space-based observatory. It is the result of many years of innovation by a devoted team, which anxiously anticipates the astounding science that Roman will produce. The optimal operating temperature for the detectors is -288 degrees Fahrenheit, or -178 degrees Celsius. Roman's detectors are so sensitive that adjacent wide-field instrument components must also be cooled, otherwise their heat would overwhelm the detectors and blind the observatory. The radiators will divert waste heat from the instrument's components away from the detectors and into cold space, enabling Roman to detect faint signals from distant galaxies and other celestial objects. Roman's camera will be complete and available for thermal vacuum testing in the summer of 2023, once the radiators are installed. The entire WFI is expected to return to Goddard in the spring of 2024, where it will eventually be integrated with the remainder of the observatory. Recently, a vital subsystem for NASA's Nancy Grace Roman Space Telescope was delivered to Ball Aerospace in Boulder, Colorado, and installed in the Wide Field Instrument of the spacecraft. This component, known as the Simplified Relative Calibration System, SRCS, will enable astronomers to precisely measure the total light emission of cosmic objects such as galaxies and supernovae. When Roman is launched in May 2027, scientists will use this data to uncover the mysteries of dark energy and dark matter, discover exoplanets, and investigate a variety of infrared astrophysics topics. In February of 2020, the mission achieved a significant programmatic and technical milestone, giving it the official go-ahead to commence hardware development and testing. Roman also passed its critical design evaluation in September 2021, signifying that all design and developmental engineering work has been completed. The Roman team is presently constructing and testing the observatory, to ensure that its design will withstand the harsh conditions of launch and spaceflight. The combination of the Nancy Grace Roman Space Telescope's high resolution and enormous images is unprecedented for a space-based telescope, and will make it an indispensable instrument in the future. Thank you for watching.